Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 12th April 2023. The problem statement for today is dominant pairs. This problem is based on sorting and two-pointer algorithm. Let's now open this problem to solve it. We will first go through the given problem statement. Here it is said, you are given an array of integers of size n, where n being even. You have to calculate the number of dominant pairs, where a pair is called dominant if 0 less than equal to I less than n by 2 and the range of j is n by 2 less than equal to j, which is less than n. And this should satisfy the condition that array of I is should be greater than or equal to 5 times array of j. Okay, so if this relation is fulfilled, then we can call that pair as dominant pair. For example, in array 10, 3, 3, 1, index 0 and 3, that means for index I is equal to 0 and j is equal to 3, form a dominant pair. Because if we try to get this one, array of I, that will be 10, and that is of course greater than or equal to 5 times the value of j here, which is 3. The index value of j is 3, which is leading to the value from the array that is equal to 1. So 10 is obviously greater than or equal to 5. There is 5 into 1, that will give 5 only. So I hope this problem statement is clear. That means we have to find the number of dominant pairs which will satisfy this condition. That means the range of I will be equal to the first half of the array, and j's range will start from the second half of the array. And for each half we have to find this pair which satisfies the condition array of I should be greater than or equal to array of 5 times the array of j. Okay, let's go through the given examples to understand it in a better way. So here the first example says the size of array is 4 and the array elements is 10, 2, 2, 1. So here the output is 2. As we can see here that at index I is equal to 0 and j is equal to 2. This one, index I is equal to 0, that means the value is 10 here, and index j is equal to 2, the value is 2 here. So here we can see that array of 0 is greater than 5 times array of 2, that is equal to 10 is greater than or equal to 10 is fulfilled. So this forms a dominant pair, and in the same manner index I is equal to 0 and j is equal to 3 forms a dominant pair. So total 2 dominant pairs are there. If we look for j is equal to 3 also, so here also this condition satisfies, because that time it will be 10 greater than or equal to 5 into 1, because this time j value is 1 for the second dominant pair. So even that condition holds true, so we get 2 dominant pair here. If you go to the second example, then here it is said that size of the array is 6 and here the output is 5. We can see that index I is equal to 0 and j is equal to 3, where array of 0 greater than or equal to 5 times array of 3. That means, yeah, the same thing here. That means 10 greater than or equal to 5 is fulfilled. So this forms a dominant pair. And in the same manner, the pair of indices like 0, 4, 0, 5, 1, 3, 1, 4 also form the dominant pair. So total 5 dominant pairs are there. Okay, so first we checked for this and 1, but if we look at for in position 0 and 4 also the same, the condition will be satisfied. For 0 and 5 also the condition will be satisfied. Okay, and similarly for 1 also, the 1 and 3 and 1 and 4 the condition will be satisfied. So we get total 5 dominant pairs here. So I hope this both of these examples are clear. So here the approach we can use here is to sort both halves in ascending order. Then we can use 2 pointers I and j to iterate over both halves of the array simultaneously. And our goal is to find all the pairs of ij that satisfy the condition. Which condition? This entire condition. The range of I should be up to n by 2 and range of j should be starting with n by 2, but it will go up to n, and this should satisfy, this pair of ij should satisfy the condition that array of I is greater than or equal to 5 times the array of j. Since both half of the array are already sorted in ascending order, we can use two-pointer approach to count the number of such pairs. If the current if the current pair ij satisfies the condition for the dominance, then all the elements to the right of I in the first half will also satisfy the condition. Therefore, we can increment the dominant pair count by the number of elements remaining in the first half and move to the next element in the second half. If the current pair does not satisfy the condition, then we can move to the next element of the first half. Okay, and finally we return the count of dominant pairs. Okay, so this approach we will be using here. So I'll just explain it, whatever the approach I have told you, with one example. So let me open that. So actually here I have taken the second example which was given here in the problem statement for explaining this. Okay, so what we are doing, so first we are dividing it into two halves. So the first half will contain 10, 8, 2, second half will contain 1, 1, 2, and we are sorting each half separately. So after sorting it became 2, 8, 10, and second half will become 1, 1, 2. It was already in sorted order only, so that's why no changes there. Now initially, since we have got the range defined for I and j, I will be first pointing to 0 and it will go up to 2, and j will start from 3 and it will go up to 5. That means n minus 1, and here it is first half up to index less than half of the index. Okay, so for each of this pair we will check this condition. If array of I satisfy the condition, that means array of I is greater than or equal to 5 times the array of j, then we will assign this dominant pair count, increment this dominant pair count value by n by 2 minus I. Okay, so here the reason for that is that all the elements to the right, if this condition is satisfied, then all the elements to the right of I in the first half will also satisfy the condition for the same value of j. Okay, so I'll explain it in detail here. So let's try and see what will happen in the first step. So here, if we here j I is pointing to 0, so that means pointing to 0, that means array of I, that will give 2, and array of j will give 1 here. So here we'll check that is this condition satisfied. Then here we can see that 2 greater than or equal to 5 into 1, this condition is not true. So what we do, we increment the value of I by doing I plus plus. So now I will be pointing to 1, but j will still be pointing to 3. Okay, now we check. Now what is the value at index position 1 for first half? That means the pointer which is indicated by I. So here the value is 8. Okay, and here the value is still the j is pointing to the index third, that is the first element of this second half, that is still 1. So now we will check the condition. So what is the value here? 8 greater than or equal to 5 into 1. Yes, so this condition is true. So if this condition is true, what we do? We increment the dominant pair count by n by 2 minus I. Initially dominant pair count value was 0. Okay, let me just write that so that it becomes clear. If initially it was 0, so now the value of dominant pair count will become n by 2 minus I. N by 2 minus I means what was n here? N was 6, n by 2 will give 3 minus I. What is the value of I? I is 1 here. So this dominant pair count value will be 2. Why we are doing this? We are doing this for a particular value of j. if one condition is satisfied, if the current value of I is satisfied, then since it is in increasing order, then all the elements to the right of it, now currently it is at 8, if 8 is satisfied for this value of j, then it is obvious that even 10 will be satisfied because it is in ascending order. If 8 is greater than or equal to 5 into 1, then it will happen that it will definitely be that 10 will definitely be greater than or equal to 5 into 1. Okay, so for any value of j, if current value of I satisfies that condition, so all the elements to the right of I, that will automatically hold true for that. That's why we are checking that how many elements are there after that. Okay, so we are getting this value 2 here. I hope this is clear. That means we will not individually check for I. We will not individually check for next value of I for this particular element. For subsequent element, the similar approach will happen. But for this value of j, we will not check the further element from the first half, because the previous one is satisfied, so this will automatically be satisfied. Okay, so now we have got 2 here. So now what we do, once this is true, then when we assign this one, then we increment the value of j. So here now j will become what was j? J will become 4 now. J will become 4 now, and I will be 1. Okay, so now we are checking again. What is the value of I here? I is I is still the same thing. I is still pointing to 8, and even the next value of j is 1. So it will still holds true that this condition is true even for this one. That means I is equal to, I is pointing to 8 and j is pointing to this 4. With j index value as 4, it is pointing to this 1. So this still holds true. So again we will check the same condition. If this condition is true, then increase the dominant pair count by the same, n by 2 minus 1. So even like the previous step, where j was pointing to this 1, and we checked that for 8 it was valid. Similarly, even now the value of j is pointing to 1 only. J is pointing to this 1 only. So again we will again conclude the same thing. If for this value of j, if 8 satisfies that condition, then even 10 will satisfy that condition. So again we will not do separate calculation for 10 for this particular value of j. Okay, so here again we will add to this dominant pair count. It was initially pointing, it had the value of 2. Now we will add to this. What will add? Initially it had 2. Now we will add n by 2 minus I. Again n by 2 again will give the 3 minus 1. See, because I is still pointing to 1 only. So here the value will be incremented by 2 again. So it will be 4 as of now. Okay, so now next time again we will increment the value of j. Now now I is pointing to still 1 and j will be pointing to 5. Now j will be pointing to 5. Now we will check this condition. That array of I is greater than or equal to 5 times the value of j. So here now 8 I is pointing to 8, but this one j is pointing to 2. It has crossed 1 and it is pointing to 2. So now the condition will become 8 greater than or equal to 5 into 2, which is 8 greater than 10. This condition is not true. When this condition is not true, we are going to else block and we increment the value of I. So now here the value of I will be incremented to 2 and j will still be pointing to 5. Okay, so now what we do? Now again it will go for the next iteration and it will check. that if this condition holds true for I is equal to 2, that means it is pointing to now 10, and j is pointing to 5. That means j is pointing to index value of j is pointing to this 2. So now the condition will be for this, that 10 greater than or equal to is 10 greater than or equal to 5 into what is the value of j, which is pointing to j is pointing to the value of 2 in this array. So the value, see, the condition will be this, 10 greater than or equal to 10. Yeah, the condition is true here. Okay, so now what we do, this condition is true, so now to the previous count of dominant pair count we add this one, n by 2 minus I. So earlier the dominant pair count value was it was 4. To this we add n by 2 minus I. So n by 2 is 3, but now the value of I is 2. 3 minus 2 is 1. So the value will become 1 here. So it will be 5. Okay. So after this we increment the value of j. So it will go out of this loop, and the while loop in which this is running, so that will not satisfy this condition and it will come out of the loop. So after coming out of the loop, we will check this dominant pair count, that will contain the value 5 there. Okay, so that only will be returned as the output. Okay, I hope this example is pretty clear to everyone. So we will solve this one using the same code, same approach, whatever we have just talked right now. So I have prepared one solution. Okay, so before moving to that, actually see, here we are sorting it into two half. We are sorting it in two half, we are dividing it into half and sorting it. So the reason of sorting is that we can get calculation through this one. So as you saw in this example, that if for any value of j, if the current value of I and the condition is true, then we are not checking for the all the elements of I on the right side, all the value of I in the particular first half on the right side, because it is since it is in ascending order, so even this, if this is holding true, then even the further elements will hold true. So we directly add the count here, we do not check separately for that. Okay, so this gives the benefit when we sort the element into different half. If we are not sorting, then we had to check for each element in the first half with each element in the second half using two for loops. So that would have been the brute force approach, and that was giving some time limit exceeded error. Okay, so before trying with this solution, I'll first show you that how I was getting that brute force algorithm, that error. So let me try running this code first. So initially I was trying with this. So here I've divided into two half, and just for each half, for each element in this for loop, I was checking whether this condition holds true. If that is that, if this holds true, then I was trying to increment the count. Okay, so for each element in I was checking for each element in j. So if I try compiling this code, so the test condition here it is given, that will satisfy. But if I try submitting the solution, so it will give time limit exceeded error. See here, it gave time limit exceeded error because it has to check for each element of I to the corresponding each element of j. So it will be in the order of n square times. Okay, so for improving this time complexity only, I have to sort it in, just a minute. Yeah, so I've sorted it in two half, so that we could achieve whatever it was there with that condition, with the example which I have explained, that this dominant pair count, that without the need of checking for the further element of in the first half using index I, we can directly add them in the dominant pair count. Okay, so now let's try the enhanced code or the optimized code here. So this is the solution. Again, we have not done anything. The same thing, the logic, the complete everything the same, whatever I have explained in the example. So what we do here, we initialize the dominant pair count to 0. Then we sort both half of the array in ascending order from 0 to n by 2 and n by 2 to n. Then we initialize two pointers I and j to the first element of their respective halves. Okay. Then iterate over both the halves of the array simultaneously while I is less than n by 2 and j is less than n with this condition. Okay. Then we check if the current pair of array of I and array of j satisfy the condition of dominance, which is array of I is greater than or equal to 5 times the value of j, that value of index position j in the array I, in that array, given array. So if array of I greater than equal to 5 times array of j, if this condition holds true, then yes, then increment the dominant pair count by the number of elements remaining in the first half, that is n by 2 minus I. Here actually it will be the first half. Okay. Now what we do, if so once we have taken that consideration, then we will move to the next value for the j. Okay. But if this condition is not true, then what we do, we move to the next element in the first half only. Okay. This is the same thing. That means whatever I have explained here, where it was, yeah, here, if this condition was true, then what we did, if this condition was true, we counted that for value of 8, that means value position of I is equal to 1. Then what we did, we incremented j value so that I was still pointing to 1, that means 8, but j moved here, so that we have with this only we could check that the condition which was valid for 8, is it valid for the condition which was valid for j is equal to 0 here, is it still valid for j is equal to 1. Okay. So for taking that benefit only, if we have sorted this, we have got this element sorted and we have counted all for this, then we are moving next to this. But if this condition is not true, then we move to the next element in the first half. Okay. So now with this solution, let me try compiling this code. So here we have got correct output. Let's try submitting this solution. With the brute force approach, we got TLE. Let's see with this. So see, with this one, we have got all the test cases covered here. So this problem has been solved successfully with Java language. So this was the Java solution of it. So talking about the time complexity of this solution, it is in the order of big O of n log n, where n is the size of input array. The dominant pair function first sorts both halves of the array using the built-in sort function in big O of n by 2 log n by 2 time for each half. The subsequent two pointer approach takes big O of n time as both pointer I and j traverse a respective half of the array size only once. Therefore, the total time complexity of the function is big O of n by 2 log n by 2 plus big O of n by 2 log n by 2. These two are for sorting the two half of the array, and to this we add big O of n, which is that time complexity for traversing the array using pointer I and j. So if we add all of this, then it will give in the order of big O of n log n. So that overall time complexity will be big O of n log n. Okay. So this was the Java solution of it. I have even prepared C++ solution. So let me just copy it here. Again the logic is completely same. Only the syntactical difference, whatever we have between C++ and Java, that only we have it here. So here the same thing, dominant pair count is equal to 0, then we are sorting it. There we use sorting different method is there. Here now different method is there. That is the difference between C++ and Java. Apart from that, everything is same. All the logic completely it is same. So let's try compiling this C++ solution. So here we can see we have got correct output for the given input. When I try submitting the solution, even this should be correct because the logic is completely same. So see here also we can see we have got the correct output for this. Okay, so this was the C++ solution and previous one was Java. Okay, so with both these languages this problem has been solved successfully. So I'll provide the link for this question and the code for this question, this solution in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.